The scale drawing shows a garden with two trees, P and Q. The scale is 1 centimeter represents 6 meters. P and Q, they are two trees. The garden has a path that is equidistant from P and Q. Using a straight edge and the compass only, construct the path. So the garden has a path that is equidistant from P and Q. In other words, we have to draw the locus of a point which is equidistant from P and Q. Locus of points equidistant from P and Q is perpendicular bisector. By taking compass, we will open the compass more than half of the length of PQ. Q will be taken as center. We will draw two arcs on two opposite sides, and then keeping the length of the compass same, P will be taken as center and we will draw two arcs on both sides which will intersect arcs already drawn. Then we will use ruler to join these 2 points of intersection, equidistance from P and Q. Yuna wants to plant a third tree in the garden that is nearer to Q than to P and more than 18 meters from Q. Shade the region where Yamuna can plant trees. More than 18 meters from Q means type of the locus which is at a given distance from a fixed point. So in this case, since it should be more than 18 meters, so 18 meters in actual 3 centimeters on the paper. The scale is given 1 centimeter is equal to 6 meters. Q would be the center and we will draw a circle of the radius 3 centimeter in the garden that is nearer to Q than P. More than 3 centimeter is outside this circle and closer to Q as compared to P. This region would be the one which we should have. Circle, radius 3 centimeter, center Q. Two conditions are there, nearer to Q than P. It should be on the side which is towards Q from the perpendicular bisector we draw. Perpendicular bisector of PQ tells us all the points which are equidistant from P and Q. So the tree should be on the side which is closer to Q. So this perpendicular bisector will be the boundary, Q side of the perpendicular bisector and outside the circle. Question number 12. The diagram shows a rectangle ABCD. E is a point on the diagonal AC such that DEC is 90. Prove that the triangle ADC is similar to the triangle DEC. ADC and triangle DEC. DEC is this triangle. Angle ADC is equal to angle DEC. Both are 90. It is given ABCD is a rectangle, so ADC will be 90 as well. This is the corner of the rectangle, both 90. Second is angle ACD, that is equal to angle DCA. ACD or DCE, actually they are same angles, so they are common. We can call this angle ECD, we can call this DCE, we can call this ACD or DCA. So ACD and DCE, that is common. The angle DAC is equal to angle EDC, third angle of the triangle. Because if two angles of a triangle they are equal, the third will be 180 minus the sum of those two angles, so definitely that will be equal. Hence shown. Hence triangle ADC is similar to triangle DEC. The reason AAA test. Write this in these lines. Question number 13. The mean of 5 numbers is 17. So there are 5 numbers. The numbers are listed in the order of size starting with the smallest. The 3 smallest numbers are equal. X, X, X. The middle 3 numbers add to 35. The largest number is 4 times the smallest number. The largest number is 4 times the smallest. 4 times the smallest. The middle three numbers, they add up to 35. If the mean number is 17, so what will be the sum of 5 numbers? That would be 5 times 17. And if the mean is 17, so 17 times 5 will give the sum of all 5 numbers, 85. So it means x plus 35 plus 4x is equal to 85. X and sum of these middle three numbers, that is 35 plus 4x. So 5x is equal to 85 minus 35. 5x is equal to 50. X is equal to 10. So 10, 10, 10. So if they are 10, 10, 10, so this is 20 and this would be 15. Because x plus y, x plus y, that is 35. So 10 plus 10 is 20. 20, when we will shift this 20 to other side, 35 minus 20 is 15. So y is 15. And the largest number is 4 times the smallest. So it would be 40. So 10, 10, 10, 15, 40. Question number 14. The diagram shows speed time graph for the start of a cyclist's journey. Find the acceleration during the first 20 seconds. Acceleration is rise over run. So here you can see rise is 15 over 20. So 15 over 20, which is 5 3s are 5 4s are. So 0.75 meter per second square. Because rise is 15, rise over run. This is the one way. Other way is in speed time graph, acceleration is the gradient. So basically rise is y2 minus y1 over run is x2 minus x1. So if you take these 2 points, take any 2 points from this graph, that is 20 and 15. The other one is 0, 0. So 15 y2 minus y1, 15 minus 0 over 20 minus 0. Again we will get 15 over 20, which is 0.75. We say change in speed or velocity over time. It has changed from 0 to 15 in 20 seconds. So change in speed is 15 from 0 to 15. So change is 15 over, it took 20 seconds to divide by 20. So that is the third way. Describe the motion of the cyclist from T20 to T30. T20 to T30, cyclist was moving with a constant speed of 15 meters per second. Moving with a constant speed of 15 meters per second. Find the total distance traveled in 50 seconds. Total distance traveled in 50 seconds means we have to find, in case of speed time graph, the distance is calculated by finding the area under the graph. So we need to find this whole area. If we divide this region into different parts. In this case, what I am using, we have 2 rectangles and 2 triangles. So in the first left side triangle, we have height 15, 20, half times 20 times 15. So 2 tens are 150. This would be 150. And this is rectangle whose base is 10, height is 15. This will also be 150. And in this triangle we have base as 30 to 50, it is 20. Height is 5 to 15, so it is also 10. So its area will be half 10 times 20, so 100. So this is 100. In this rectangle that has this length 30 to 50 is 20 and height is 5. So 20 to 5 is 100. So the total distance will be 150 plus 150 plus 100 plus 100. So 300 plus 200. So the distance covered within the 50 seconds, total distance covered in 50 seconds is 500 meters. Question 15. During 1 year, the value of bicycle decreased from 200 to 160. Calculate the percentage decrease in the value of bicycle. So it decreased from 200 to 160. The first thing we need to do is to find the decrease. The amount of decrease is 200 minus 160, so $40 decreased. To find the percentage, 40 divided by the actual price, not changed one. We will use 200 because actual price was 200. So we always use the actual price as the denominator. So 40 over 200 multiplied by 100%. So decrease percentage means decrease. How do we find decrease percentage? Decrease divided by actual amount. Actual means starting amount, which is not changed. Multiply by 100%. So 2 zeros with 2 zeros cancel to 20. So 20% will be the answer. Question number 16. Solve the inequality. 23 plus 2n is greater than 5 minus 6n. So 2n, we will shift this n term from right to left, it will become plus 6n. Greater than 5, we will shift this 23 from left to right, 5 minus 23. This is 8n is greater than minus 18. We will subtract 5 from 23 and the sign of larger number will be with the answer. So n is greater than minus 18 over 8, or we can say n is greater than, we will simplify, 2 9s are 2 4s. So it is minus 9 over 4. Then question number 17, factorize. 4 terms are given. The 4 terms mean we will do grouping. 3xy minus qy, make this one group. Another group is 6px minus 2pq, the other group. So we can take y common from the first group. So we were left with 3x minus q. From the second group we can take 2p common. That will make 3x minus q. 2p is taken common, so q. So in the next step we can take 3x minus q common from both, and we will left with y plus 2p. So 3x minus q, y plus 2p. Question number 18. The diagram shows a shaded region ABC. The equation of the line AC is y is equal to minus half x plus 5. Write down the 3 inequalities that define the shaded region. So we are given the equation of AC, which is y is equal to minus 1 over 2x plus 5. The shaded region has 3 boundaries. That is the reason this region will be defined by 3 inequalities. To define 3 inequalities, we need all 3 equations which are the boundaries of this shaded region. So one equation is y is equal to minus 1 over 2x plus 5. This horizontal line BC is y is equal to 2. And the third one, AB, which is the vertical one, is x is equal to -4. So these three equations are required to write the inequalities which are defining this shaded region. We have to replace these equality signs by inequalities by observing the relationship of the shaded region with these lines. Here you can see for this inclined line, whose equation is y is equal to -12x plus 5, the region is below it. The shaded region which we are going to define is below it. So below it means the region is lower, means less than or equal to. So y is less than equal to -12x plus 5. And for the second case where we are taking BC is a horizontal line and the region which we are defining, the shaded region, is above it. Above means greater than equal to. Since the boundaries are solid lines, so we are writing greater than and equal to. And the last one, the third line, which is the vertical line, the region is on the right of it. Right means x is increasing on the right. It will also be x is greater than equal to -4. So these are the three inequalities. In the first inequality is y is less than equal to -12x plus 5. The second is y is greater than equal to 2. And third is x is greater than equal to -4. So these are three inequalities which define this shaded region. So to define a shaded region, we need the equations of its boundaries, and then we replace the sign of equality by using appropriate inequality.